Hello, everyone. Welcome to the eighth episode of Rendezvous with the Stalwarts, the show where we discuss the journey of stalwarts in our profession and talk with them about their experiences, projects, and their vision for the future of our industry. I'm Daniel Couture, your host for the show, and in today's episode, it is truly a pleasure to be talking to Jim Malley. Jim has had over 38 years of experience in the space of seismic design, evaluation, and rehabilitation of building structures while working with Degenkolb. He had been responsible for the analytical and testing investigations performed as part of the SAC Steel Project in response to the 1994 Northridge earthquake damage, and is also heavily involved in the seismic peer review of numerous tall building projects in areas of high seismic risk. He has also received a number of prestigious awards along his career, and most importantly was recently honored election to the National Academy of Engineering. So without any further ado, let's move straight into our conversation with Jim. Congratulations, Jim, on your recent award, and welcome on today's episode of Rendezvous with the Stalwarts.
Thank you, Daniel. Looking forward to it.
Yeah. So, Jim, I'd like to start by jogging your memory during your growing years to know more about what it was that drove you towards getting into civil engineering and then pursue a specialization into structural engineering.
Sure. Well, I'll have to say that it wasn't the most direct path, but there are really no people within my family that are in the technical area or engineers of any sort. So, as a young high school student, I sort of did well in math and science, and my guidance counselor said that it seemed like my interest might lean toward engineering, so I looked into it a little bit before.
Okay.
And then actually applied to Berkeley, where I went to school, in engineering, but in mechanical engineering originally.
Okay.
And it was at the time when we had just had the energy crisis in the mid 1970s, and the oil industry was really the place where a lot of energy was being going in the profession. So I thought, well, maybe I should look into that. Well, by the end of my freshman year at Berkeley, I realized that mechanical engineering wasn't really a good fit for me, because I didn't like to fool around with cars or do things like that. So I looked into the other disciplines, and civil engineering seemed like a better fit for me, being sort of more public faced and the infrastructure, things that you could see every day. So that's really what sort of led me to civil engineering. And then as far as why structural, as I took the classes, I'll have to say I was a little bit influenced by my advisor, who was Professor Jack Balkamp, who was a structural engineering professor.
Okay.
And as I was going through the classes, he really sort of led me to stay in school and get a master's degree, and really and taking the classes at Berkeley, seismic engineering and seismic design is really a really huge part of the civil department in the structural engineering group.
Yes.
And so that seemed just like a natural fit for me, and I enjoyed those classes, and that's kind of how I ended up in structural engineering.
So I'll just follow up on that. So you completed your bachelor's and master's from UC Berkeley. So Could you share with us your journey there and what it is that makes UC Berkeley special for bringing out so many stalwarts in our profession? Like literally every other person that I look up to in our profession, and when I go to their profile, they have graduated from UC Berkeley. So do you consider being at UC Berkeley shaped your career tremendously?
Oh, absolutely. Yeah, no, without a doubt. I mean, it was an amazing place to be at that time in structural and earthquake engineering, obviously. When pretty much every class we took, the person that we took the class from, the professor that taught us that class was probably the number one or number two person in that area in structural engineering at the time. So the faculty there was amazing, and in general, they were all great teachers too. They were great researchers as well as really good teachers. And I think the other thing about it was the reputation was so high then, back then, and it still is. But the reputation was so good that it drew the best students as well. And so there was great interaction with the students, and we, learned from each other, and there was a lot of competition to really succeed in the classes and things. So I think that was definitely part of it. And when I started my master's program, I decided to do a 2-year program rather than a 1-year coursework only program, and that included doing a little bit of research.
Okay.
And at the time I said, well, I'm not really in that big a hurry to go to work full time.
Yeah.
So maybe I'll do some research. And I was incredibly lucky in the research that I was able to do with Professor Popoff, who is sort of a legend in seismic design and steel design.
Yes.
And so the project I was able to work on was the eccentric development, helping with the development of the eccentric brace frames system, which at the time was not in the building code. It was being developed there were 7 of us that worked on it, 6 PhDs, many of whom you would know, as well as myself being the only person who was just had a master's program. So what an incredible opportunity, right? And then toward the end of my master's studies and research, Professor Popoff's funding ran out for the project. And he said, and I was coming up on a summer before finishing in December of that year. And he said, oh, I don't have funding to keep you on and finish your research during the summer, but I'll get you a summer internship. He said, I'll call Henry Degenkolb. And so I ended up spending an internship there, and then they offered me a position back when I finished graduate school at the end of that year. So how else could it have impacted my professional career any more than it did, really?
So how has your journey at Degenkolb been? You started there and have been there throughout your career and are still working with them. So how is your experience there, and how is the culture there that kept you for so long?
Right, sure. Obviously, I'm a dinosaur in today's world, right? My entire career with one firm, but it's been a firm that's been amazing to me and given me everything I could have ever hoped for in career opportunities. And the culture is really, in my mind, very supportive of that. And that, we try and make it so that our engineers do have lots of opportunities, can find a path that they can really thrive in and make their careers really successful and make it what they want to be. Really, the structure is intended for them to find that path and follow that path. We don't really send them down a path. We want them to explore and find a path that's going to be successful for them. And that certainly was the case for me. I've had great project support, different kinds of projects, different challenges. And then they also let me continue to participate with the research community, and so we're very supportive of that, and being involved with professional activities, again, very much a part of the Degenkolb culture.
That's good. So Jim, along your successful and long career, did you have a roadmap in your mind right from the start on how would you like to build on your career or develop expertise in any particular domains or projects? How did you manage to upskill yourself continuously and also contribute to publications and research? Like you just mentioned that Degenkolb supported you along the way as well. You had to manage your busy schedule as well, and you also led a number of leadership roles along your career. So how did you manage yourself and upskill?
Sure. Okay. So certainly, I think early in my career, I knew I wanted to, focus on the steel and seismic design in steel, because that obviously I'd done that research on that. I knew a lot of the professors that were doing work on that. Professor Popoff continued to support me and give me opportunities to work with him even after I started at Degenkolb. And so that, that research in steel, that was something I knew I wanted to do. I pretty early on, at the time, the Structural Engineers Association of Northern California had a research committee, and I joined that right out of school. Ended up, my first committee chair was the research committee of SEONC.
Okay.
And I enjoyed that. And, and at the time we were doing some good work to help translate research results into practice. And I thought that
Yeah.
was interesting and something that I feel is really important for us to continue to do.
Okay.
But other than that, not really, but it really, that I had a roadmap that I really wanted to follow, right? But it was, again, the opportunities that were put in front of me at Degenkolb
Yeah.
helped me to find that path. And very early on, I worked on a major retrofit for a hospital in Oakland that we did some really innovative work with steel brace frames to retrofit that hospital. And then I had this amazing opportunity called ATC 14.
Okay.
And in today's world, you think of existing buildings, seismic evaluation, seismic retrofit, you think of ASCE 41. Well,
Yes.
in the early 1980s, there was nothing on how to do seismic evaluation or retrofit. Basically, every
Yes.
engineer did it the way they felt was
Yeah.
appropriate.
Yeah.
And so ATC got some funding from FEMA to start to look at that, and because it was becoming more and more obvious that we really needed to put much more focus on our existing building stock, because that's where a lot of the hazards, or the most severe hazards, are going to be from the
Yeah.
next earthquake.
Yes.
And so Degenkolb got the project. Chris Poland was the leader of the project, and I was selected to be the engineer, the project engineer that worked on that.
Okay.
And it was an amazing opportunity because they put together a group of a very talented group of project engineering panel, about a dozen engineers that were involved in that world. We also went around to probably 15 different structural engineering offices in California.
Okay.
And interviewed the principals of the firm at the time that were doing existing building work about how
Yeah.
they did it and what they did.
Yes.
And we really put together the framework that is, you'll see actually within ASCE 41 today. And so it was the very first project that sort of started that pathway. I call it ATC 14, I think the great grandfather of ASCE 41, because there were 3 or 4 projects in between that led to ASCE 41. So again, great opportunity to really understand and immerse myself in the world of existing buildings. And then obviously, hard to believe, but both the Loma Prieta earthquake and the Northridge earthquake had tremendous impacts on my career. The Loma Prieta was, we were working with the Department of Veterans Affairs on a major hospital they have down in Palo Alto, California. And we had been studying the 1960s buildings that were designed there in the 1960s for their seismic vulnerability. And just prior to the earthquake, had proposed a retrofit and expansion plan for the hospital with the architect that we were working with to the VA. And the VA said, gee, that's really too much money. We can't afford that right now. So that was in August of 1989. And in October of 1989, the earthquake hit not too far from Palo Alto, damaged the buildings pretty much exactly the way we told them they were going to be damaged. They had to evacuate the hospital. And almost immediately we had a project that was double the size to replace the entire facility with a brand new steel frame structure. And guess what? We used eccentrically braced frames to design that building. So a great opportunity there. And then as we were sort of completing that design a few years later, the Northridge earthquake hit. And the damage to steel frame buildings that occurred was a great surprise to the profession. And because of my connections in the seismic design and steel and research, the SAC joint venture that you mentioned earlier was formed with FEMA funding to look into this and try and pull this together. And the leadership of that group was Steve Mahan, the late Steve Mahan, who was a professor at Berkeley that I was a TA for back when I was there, and we'd stayed close. And he and the other leaders in the group asked if I wouldn't help them be the director of all the research that went on in that program. And it was a 6-year program. And And Degenkolb was great in supporting me to do that, because it was essentially half of my time
Yeah.
for 6 years went into working
Yeah.
on that project.
Yeah.
And they said, Chris Poland specifically said, you have to do it. I mean, please, we're gonna make this work. And so it was an amazing opportunity, and talk about, expanding my network and in seismic design and steel. Nothing could have been better than that, and incredible learning experience for me that I now have been able
Yeah.
to help
Yes.
on our projects going forward. So
Yeah.
pretty
Totally.
amazing.
Yeah.
And I think that the juggling part, obviously Degenkolb was very supportive and gave me the time to do those sorts of things.
Yeah.
My family is also very supportive, and I've been pretty lucky, or very lucky with that, and very appreciative of that. But I always made time for my family things as well. I didn't
Okay.
sleep much for a number of years, maybe,
Yeah.
but I coached my sons in their athletics and in baseball and basketball for their entire period growing up, and never missed an activity of theirs unless I was traveling, but I tried to arrange things around that. So,
Yeah.
and so, you have to keep that balance, right?
Yes,
Otherwise,
definitely.
your things are going to unravel on you. So,
Yeah.
uh,
Yeah.
but it was definitely, there wasn't too much downtime for sure for many years. Yeah.
Yeah, that's great. That's great. So, Jim, for all the younger engineers who desire to gain expertise in the domain of seismic and design, could you share with us what are all the books or publication standards or references that they should go through or set themselves up to if they want to gain good knowledge and understanding on that subject, if they are not currently working on such kind of projects or something like that, and they aim to work on such projects in the future?
Sure. So obviously, ASCE 7 for
Yeah.
the loads, chapter 12, 11, and 12 are the most
Yes.
important there. And for all these standards, and I'll talk about the AISC standards, the seismic provisions, AISC 341 and 358, which is the
Yes.
standard on moment connections, moment frame, special moment frames. The really important things to always remember is the commentary, because the
Okay.
commentary explains the why part, right?
Yes.
So
Yes.
the provisions themselves tell you what to do,
Yes.
but they don't tell you why,
Yeah.
or why it's important, or what the reasons behind the way it's put together. And so I would
Yes.
always, and when I get questions from engineers in the firm about something and I don't know the answer right off the top of my head, which is a lot of times,
Yes.
I'll say, did you look at the commentary yet?
Yeah.
And because and a lot of times it's there,
Yeah.
and
Yeah.
or it refers to a research project that tells you the detail of the
Reason for
background.
it. Yes.
So the commentaries are really important.
Yes.
Another document, obviously the seismic design manuals, both
Yes.
AISC seismic design manual for steel,
Yes.
and then the SEOC has a great series of seismic design manual documents that they have
Yes.
that have step-by-step examples for very common design tasks that
Yes.
would be very helpful to young engineers as they're starting to develop their skill set.
Yes.
Other things I would suggest are the NEHRP provisions,
Okay.
which FEMA funds. The National Earthquake Hazard Reduction Program is NEHRP.
Okay. Okay.
And that is sort of the proving ground for the ASCE 7 provisions. So
Okay.
all of the new thinking, the new systems that come through first are in the NEHRP provisions and then move their way into ASCE 7. So, and they have a lot of great commentary there, a lot of background information there.
Okay.
They also have a section that is really not intended to become code language eventually, but again, we call them white papers, which are background papers. There's a great one in the edition we have right now on the concept of resiliency and functional recovery and those sorts of things, and that's really a new frontier for us, and that's where a good place to see some of these new ideas is in the NEHRP.
Yeah.
And then two books that I think are great references. The first one on steel design is called Ductile Design of Steel Structures.
Yes.
And the authors are Michel Bruneau, Cha-Ming Wong from UC
Yeah.
San Diego, and
Yes.
Raphael Sabelli. And
Yes.
all three of them have been heavily involved in seismic design committees, the AISC committees, and the seismic design provisions of AISC 341.
Yeah.
And in my mind, it's a great book in that it's very conceptually based, and it explains the why part, right?
Okay.
And the concepts of capacity-based design and why that's so important, and ductile members and force controlled members, and how that all puts together and really becomes the basis
Yes.
of the seismic design provision. So that's a great one for steel,
Yeah.
and overall thinking, I think, as well,
Yeah.
for not just for steel.
Yes.
And then the second one is a book called the Seismic Design Handbook,
Okay.
and it's Farzad Naeem, another famous structural engineer from Southern California, was the sort of the editor of that. And it's a
Okay.
series of chapters on all facets of seismic design. It's a really thick book
Okay.
that he pulled together experts to write the different chapters. And that has a lot of really great background material too. So
Okay.
you
Okay.
can really dig deep on a lot of
Those materials.
topics there.
Yeah.
So those are, I think, the places that I think young
A
engineers
good start
go
point for.
to find what they're looking for seismic design issues.
Great, great. Thank you so much for sharing all those resources. Yeah. So, Jim, that brings us to the end of our conversation for part one. We'll be joining you in the second part of our conversation to know more about some of your projects and some advice.